Hello, everyone. Thank you all for joining. I'm super excited to be here because it is April 1st. I do want to say happy April Fools. I did not prepare a joke for you guys, but I promise that this talk will be very serious. So thanks. So a little bit about myself. I'm Pam. I'm an associate at BlackRock, and I'm on the networking team where I focus on external DNS, ingress, and the service mesh. And so today, I really want to provide the journey of migrating from a single cluster model to a multi-cluster model with the Istio service mesh. So the talk today is going to specifically cover the Istio open source model and how we can utilize some open source solutions to mitigate some of the limitations that come with some of those models. And so this is going to be at a very high level with key considerations to take into account when implementing at scale. So moving on to the agenda. So first, as I mentioned, the focus will be on the Istio open source deployment models. I'll be covering the networking model, the mesh and identity, and the control plane model. I won't be covering the tenancy model, but there are options with the cluster, namespace, and mesh tenancy. And just how some of the use cases, depending on what features you need for your multi-cluster mesh, can be considered with the advantages and disadvantages of those models, and just configuration when it comes to secrets, etc. And then I'll be covering some challenges. This includes like some configuration complexities. It includes the observability side, and it also includes some lifecycle management when it comes to onboarding new clusters and decomming other clusters. And so the focus will be on the observability probes. This is going to be on the east-west traffic and also the north-south traffic, and how, as a platform, you want to be alerted beforehand when you do have applications that aren't working over your ingress or over your service mesh, to make sure that you're having that uptime and that you're not relying on application teams to go and tell you when there's a problem. And then lastly, I'll finish with ambient and just touching on now that it is GA as of Istio 1.24. And so the model today will be focused on a sidecar model, but with some key considerations to close out how you can utilize ambient. So moving on to our network model. So with a network in this case, it is a reference to the workload instances having direct reachability with each other. So you have different options, and you can mix match these models. So with the single network model, this is the simplest implementation of the network model. And with this model, you essentially have your services that are not utilizing any Istio east-west gateway, but instead having direct reachability with each other. And so with the single network model, there is another consideration where this does not allow for overlapping virtual IP or IP addresses. However, with the multi-network model, it does have some features that you can utilize, such as the overlapping virtual IP and IP addresses, but also you no longer have your workload instances directly reaching each other, and you are utilizing that Istio east-west gateway. This can be seen as a bottleneck. However, one thing I want to call out is, in addition to having those overlapping IP addresses, you have more fault tolerance with your services being more over smaller networks rather than one large network. And also, it allows for more segmentation by being able to distribute these addresses over those smaller networks. And so moving on to the control plane model. So with the control plane, in this case, it is the Istio-D control plane, which is responsible for the configuration of your services communicating over the mesh. And so your workload instances will connect to your Istio-D control plane, and they'll go and pick up their configuration. And so there's various levels of availability when it does come to this control plane implementation. That includes across multiple zones, regions, clusters. And so from lowest to highest availability, you do have that primary single control plane per your region, or multiple control planes per your region. And then the next level, you would have that single control plane per your zone, or multiple control planes per your zone. And then at the highest availability, you have multiple control planes across your clusters, where each cluster can have its own control plane. And so there are some advantages to these various levels of availability. You are able to roll out with more granular configuration your Istio-D control planes. And you don't have to worry about when an Istio-D goes down, having that impact across the other remote clusters that are multi-primary clusters that do have that control plane. And so one thing I do want to touch on with the highest availability of having that multi-primary per every cluster is you do get the additional benefits of reducing that blast radius when a control plane does go down, but also when it comes to rollouts of your deployments. For example, with your tenancy, let's say you have a client or business segment to a specific cluster versus to a shared cluster. Perhaps your client cluster can't be rolled out at a certain release time. So you do have that advantage there. But also, there is some things that I want to point out with the control plane model, and that with the primary remote setup, you can have your remote clusters connect to your control plane in your primary cluster, or you can have your remote cluster connect to an external control plane. For example, some cloud vendors may provide this. Versus in the multi-primary setup, now you have remote secrets. And so with these remote secrets, they essentially have the credentials to be able to expose these service endpoints across the Kubernetes API server. And so there is some things that I do want to call out with these remote secrets. One being that when it comes to the management of these remote secrets, you want to make sure that you are rotating these secrets. And in addition to rotating these secrets, you have to consider the management of what happens if they expire. The Istio-D control plane will temporarily have access for a little bit before it releases those endpoints and no longer has access to those services in your service discovery in that multi-primary setup. And so you have to take into account the management, but additionally, what I do really want to highlight here is the security concern when it comes to those remote secrets, because essentially those remote secrets have access to read all the secrets across all namespaces in your multi-primary cluster, so from your hub to your spoke in your cross-cluster. And so when it comes to your prod environments, this most likely is a no-go because you don't want to have Istio-D reading all the secrets, irregardless of if they're specific to Istio secrets. So clearly you have more isolation when it comes to not having to deploy these remote secrets. The other thing that I do want to call out here is that when it comes to Istio-D having access to all your Kubernetes API servers across your multi-primary setup, Istio-D essentially needs to have a reference of the entire state of the world across all your Kubernetes API servers. And so when you have a multi-cluster setup that scales not just even 50, but hundreds of clusters, Istio-D can become overwhelmed and start to crash when it comes to that scale. So you really have to consider the design of having how many spokes to a specific hub, because you don't want to overwhelm that hub. And you need to consider that separation when it does come to that scale. And so moving on to the mesh model, here, of course, the mesh model, with the mesh being the infrastructure layer of the service communication that allows for that secure and observable communication. Again, you have the single mesh model, but you also have the multi-mesh model, and it's similar to this network model in the sense that the single mesh model is the most simplest implementation of the mesh model. With the single mesh model, you're not having your services or workload instances communicate over multiple meshes, but rather in the same mesh. And so those services are unique services. There is no service name or namespace reuse here. But when it comes to the multi-mesh model, you do have service name and namespace reuse. However, your services are now communicating over different meshes across different mesh boundaries. And so with this, you have to consider that if your meshes have a different trust domain, then you have to share trust bundles across those meshes in order to be able to enable those services being exposed. And so with that being said, that will take us into mesh and identity shortly after this slide. But with that, you do have the extra management when it comes to the multi-mesh model, with those benefits of if you need that use case of that service name reuse, but also if you want to not have to propagate across one mesh all services going down if that mesh is compromised, but really keeping that radius to the services in that mesh so you don't have to propagate those issues. So moving on to mesh and identity. So here I just want to highlight with the trust domain, starting with the trust domain. So the trust domain is the trust root of a system, and this is used in the identities when it comes to your Istio workload instances. And so with Istio, in terms of certificate authority, you have your root cert, your intermediate CA, and then your workload leaf certs. And so when it comes to having that authentication and that secure communication of your services across a mesh, what Istio will need is it will check two things. One, it will check, does this service have the certificate of the identity that we are expecting? And two, is the trust bundle available so that we can recognize the identities of the services that need to be discovered? And so your CA will essentially create and sign these certificates in order to create it for the workload instances. And so with a multi-mesh model, each mesh can have a different CA, and if it does have a different CA, a trust bundle will be needed to expose those services. So I did mention I wanted to talk about some open source solutions. There is Spire, which is an implementation of the Spiffy identity, which can be utilized, where essentially you have your Spire server and your Spire agents, and these allow for workload attestation by assigning these identities to your workload instances. However, one thing that I did want to call out here is with Spire, you could have some overhead in the sense that when you do this at scale, you do have multiple trust bundles that are being shared across your Spire server, and if you have multiple spokes to a hub, that can, again, cause some overhead. So another solution could be, if you do have an existing PKI already, then utilizing your external provider, you can bring Istio under your root of trust so that by default, Istio does have a root certificate and an intermediate CA, both last 10 years. But by bringing Istio under your root of trust and utilizing Cert Manager to automate the rotation of those certs, you no longer have to worry about this convoluted sharing of trust bundles and having that being exposed across this multi-mesh model. And so moving on to some of the challenges. So I mentioned first being that configuration complexity with the intricate configurations. So independent applications can have specific needs. Maybe an application has specific headers or specific retry logic or specific rewrites that they need. And so maybe this requires some additional Envoy filters in order to enable. You don't want to have to lose that functionality. So you have to take that into consideration. But also, when it comes to ensuring that there's communication that is secure across your isolated clients. I mentioned having a cluster that is to a specific business segment. You want to make sure that the communication of that business segment is not being propagated across other business segments that shouldn't be talking to it. And then you have different heterogeneous environments. You can have clusters on-prem. You can have clusters in the cloud, be it Google, Amazon, Microsoft. Moving on to the next point, we have lifecycle management. So it comes to maintaining and upgrading and managing Istio across your platform infrastructure. Like I mentioned, maybe some teams have specific release times that you need to take into account. There's also the managing of service discovery across clusters. So you have your service discovery resources, such as your service entries, your virtual services, your destination rules that can be utilized for locality load balancing when it comes to outlier detection. And so you want to be able to automate this because you don't want to have to manually consider doing this for every single application. And then the third point being, as I mentioned, automating cluster lifecycle management when it does come to decomming your old clusters and bringing on your new clusters. You might have those remote secrets across your mesh pairs, or with the multi-primary model, your remote secrets. So that also needs to be taken into account. And then there's observability when it comes to utilizing metrics and debugging, which I will touch on in the following slides. But one thing that I did want to highlight here when it comes to that intricate configuration and that lifecycle management is the usage of GitOps, be it Flux or Argo, with your templating tool, be it Customize or Helm. You can utilize GitOps to do multiple things. You can abstract the logic away from your application teams because they don't want to have they essentially just want to onboard onto Istio, and they don't want to have to configure all those intricate details and have to know about it. So when it comes to utilizing GitOps, I mentioned those service discovery resources. With the service entries with your host and with the virtual services with your destination host, you can utilize for bulk onboarding the DNS name with your wildcard prefix so that these applications don't individually need these resources across all the individual applications. And so with this, especially with namespace tenancy, if you do have your business segments within a namespace, you don't have to worry about that manual configuration. And then one thing that I also wanted to call out is there is the community project with Admiral, which is utilized for this synchronization across clusters, and as I mentioned, with those resources, enabling the deployment of those resources so you don't have to manually configure that. But the flip side being, if you do have an existing CI/CD pipeline, you can utilize that. And so I'm going to move on to the observability probes. So these observability probes have been used for multiple things. I do want to call out that Kiali is very useful when it comes to utilizing that open source solution, because you're able to see the Istio configuration across your clusters, as well as Kiali 2.7 also released some changes with ambient with the metrics as well. And so you can also see multi-cluster. It's very useful with the traffic graph to be able to see your requests going through. But as I mentioned earlier, on the platform side, you don't want to have to wait for application teams to tell you that there is a problem, but rather you want to be alerted beforehand so you can mitigate that problem. And so this observability probe is a simple Go application, and in the architecture you'll see there is a client and server. This is just for some sample service-to-service communication across the mesh. The client will periodically send pings to the server, and the server will periodically listen and serve to those pings and send a response. And so with this, similar to how you can configure Istio metrics with Prometheus and Grafana, the metrics emitted from this probe we can use as an SLI to indicate, one, our service is able to communicate over the mesh, but the second part of this probe being our service is able to register onto the mesh, and if they are able to register onto the mesh, what is the duration of that registration time? And so that is the registration job, where we'll create that pod and reached out to the Kubernetes API server to get the metrics of the init container time when it comes to the Istio status, but also check that the server has the mesh-enabled labels that is required to ensure that things are appropriately set up. And so another thing is this can be utilized with different mesh types. This was actually utilized during a migration of service meshes. And so with some simple upstream logic, when it comes to your labels and annotations, et cetera, with your client server, you can actually have different mesh labels to see this communication if it was utilized during a migration. And I do want to highlight that this is just one way to do a probe. However your SLI is needed, that can also be utilized. But it is something that we do often utilize to make sure that our SLIs are being met, and we do have that uptime that we are expecting. And so now we're pushing this toward the multi-cluster model, where you'll see that the registration is still checked within the internal to the cluster, but also there's a change now with the client and server, where the client is now reaching to its destination cross-cluster pair. So, or in this case, it's hub and spoke, internal and to its cross-cluster service. And so the client will send a request ID, request header, unique to itself, and it will be passed in upstream. And this upstream, again, utilizing your templating tools and GitOps, will essentially go and loop through every single destination to send to the server, and the server will respond appropriately. And so with this, when it comes, again, to utilizing Grafana and Prometheus, you can see with your labels now, if there's issues just not only internal to the cluster, but also from your source and your destination cluster, if there are any issues occurring. And so with this, one thing that needs to be taken into account with the configuration is you do have to enable that service discovery resource when it comes to your service entries or your virtual services if utilizing that east-west gateway. And that is just the additional logic that's needed to be able to scale this across multiple clusters. And so now moving on to the second probe, which is focused on north-south traffic. So this probe is especially useful if you are using an Istio controller for your gateway controller. And essentially what happens is we will generate a host name, and this host name, because it is periodically generated, it will check if there's a pre-existing instance of that host name, because we don't want duplicates. If there is, it will delete it. And then it will create an A record to the DNS server, and it will do a lookup on that DNS server after creation and check, is this record available? Am I able to do a lookup with external DNS? Then it will send a request through the gateway to that host name to verify the second check, which is traffic able to go through the ingress? And so this ensures that we can consistently monitor the availability of external DNS and our ingress. And one thing that I also wanted to call out here is at scale, you don't want to overwhelm your DNS servers. So when it does come to the generation of those A records to your DNS server, you can use some job randomization logic and some retry logic so that you're not consistently creating A records all the time to overwhelm it. And so I do want to say this is a very broad architecture with ingress. You can use it with an Istio gateway with your virtual services, or you can use it with the Kubernetes gateway API with routes. It's not specific to any ingress. And so lastly, I do want to end with ambient. Ambient is essentially, it breaks the L4 and L7 traffic so that you don't, essentially you have a Z tunnel with your namespaces that are using that L4 traffic, but then you have a waypoint with your L7 traffic for those specific services or subset of services that do need to use L7. And so this can cut overhead because you no longer have to worry about setting your resources when it comes to your Istio sidecars. Specifically with the Istio sidecars, there has been cases where application teams have had applications that had an increase in their load. And so Istio, the Envoy sidecar, would be overwhelmed, and there would be a crash because it was maxed on its limits and with its CPU and memory. And so they had to go and see, okay, this is being maxed, let me go and reconfigure. So that can be an issue, but ambient cuts that overhead. And so there is one thing that I wanted to call out here with the roadmap of ambient is taking into consideration with that roadmap the interoperability when it comes to ambient and sidecar. So you can slowly try and migrate to the ambient when it comes to adding new hub and spokes specific to your cluster, but you want to essentially make sure that when you do a migration, this is taken into account with wanting to enable that interoperability as there's continuous advancements being made toward it. And so with that, I just want to say thank you all so much. It's been a pleasure, and please reach out. I've had a great time speaking to you all today.